In this video, we're looking at the sine rule, but for angles. So the same formula is used when finding angles, but we flipped it. So the angles are now the numerator and the sides are now the denominator. So the formula there is sine A over little a equals sine B over B, sine C over C. Now remember, when you're finding a side, we did originally have this. So as you can see, all we've done is, depending on what we're trying to find, we've flipped it. If you're finding a side, lower cases are on top. If you're finding an angle, capitals are on top. Now it's important to note that with this formula, it can be used to find acute angles, which are angles that are less than 90 degrees, but it also can be used to find obtuse angles, which is 90 to 180 degrees. So we're going to do two examples in this video covering both types. So in this one, we need to find alpha in each triangle if alpha is acute. Alright, so how we begin is, like always, it's a good idea to label your triangles. So we're trying to find alpha. So in the last video, I stated that you always want your unknowns to be your A's. So in this case, this angle is going to be my capital A, and I know if I draw a straight line across, this is my lowercase a. Capital B, lowercase b. Write down your formula. So sine A over A equals sine B over B. At this stage, it's basic substitution. We're going to replace our unknowns, our pronumerals, A's and B's, with what their value is from our triangle. So my capital A is alpha, so let's stick with that. My lowercase a was 9. Then we have sine 59 over 11. Now, again, we want that alpha here to be our subject. So what we're going to do first is we're going to multiply this 9 up here. Now, the way I've written it there may look confusing, so what I'm going to do is actually write it out the front here. It's a little bit different to what we normally do, but you'll see in a moment why. So we get sine alpha equals 9 sine 59 over 11. We do not go 9 times 59 first. That's not what we're doing. Sine 59 is its own little thing. Imagine it's in like a little box. Alright, it is one thing. So we're not going to go 9 times 59 and have sine whatever. It is that. Alright, so down here. Now that we've got this, remember when you have sine and we want to get rid of it, we do our inverses of that. So inverse, inverse. So we're left with alpha equals our inverse. Now we're going to have a fraction, 9 sine 59 over 11. At this point, you use the calculator, put it in there, and making sure you're hitting your degree, minutes, seconds button. You'll come out that. Remember, your degrees, minutes, second button looks like that. Alright? If you're using a Casio. Alright, so now we're going to look at this example where this time we're trying to find it if it's obtuse. So, how we do this is the same way that we've done all our trigonometric questions. We start by labeling things. Now, luckily for us, our capital A is already there. Straight line across is my lowercase b and b. So, sine A over little a equals sine B over B. It's always good to write down your formulas because every time you write it down, you're more likely to remember it later on under test conditions. So let's substitute in our values. We can do our rearranging now. And that comes out as 30 and 53. Now the issue with that is that this is our acute angle, and that's not what the question wanted us to do. The question wanted us to find our obtuse. So how we do that is we have 180 degrees, and we just minus what we just calculated. So if we do that, we end up getting 149 degrees and 7 minutes. And that is our obtuse. So all you need to do to go from acute to obtuse, so if I'm trying to find my obtuse angle, it's 180 minus our acute angle that we just calculated. Sometimes you cannot have an obtuse angle, and it's important to test that, because remember, with a triangle, your angle sum is 180. So for example, if I have an angle that is 53 degrees, right? Let's say this corner down here is 53 degrees. And then I find that this angle here, this obtuse angle, ends up being 139. Okay? That can't happen because both of these numbers alone add up to being more than my 180 degrees, which means that this angle up here would be a negative, and that can't be true. So sometimes you've got to make sure that it actually makes sense, and you do that by remembering that all the angles of a triangle add up to 180.